Good evening, intermediate. I was asked to do the first part of 8.1 by a couple of people, so I'm going to do a quick video for the first part of 8.1 and watch it if you need it. Otherwise, you don't have to worry about it. So we are now in the wonderful world of quadratics. And I'm using a mouse, so you can probably hear the click, and my handwriting is terrible. Quadratics. And basically what a quadratic is it's the idea of, instead of a linear function or an absolute value function or the exponential function, now we're going to start talking about quadratics. And quadratics, when you draw them on a graph, they look like that. So the standard form, or the parent function, is what this is called, of a quadratic formula is something that you have seen before. In fact, we worked a lot with it in our last unit, and a lot of what we did was to kind of prep us up for solving quadratic functions. So the quadratic function itself, the parent function in the standard form of the quadratic equation is y equals ax squared ax squared plus bx plus c. So you may have seen this or may remember doing it when we were factoring our polynomials in our last unit. So basically, a quadratic equation is just a polynomial rather than a linear function, which is going to be just the bx plus c. And this squared piece is what gives us this curve right here. So when we're graphing our quadratic equation, it's going to create that U-shaped curve, and this U-shaped curve has a special name, and this special name is called a parabola. And it's a silly name. It looks like parabola, but it is parabola. And the parabola, we can determine if it's going to be a happy face or a sad face based off of what our A value is. So our A value up here determines whether or not it's going to open up or down. So if I were to pop this into a graphing calculator, and we're going to go ahead and use Desmos, because I can't show you my graphing calculator on here, but we're going to use Desmos. And if I graph this function right here, I'm going to have y equals x squared plus 2x minus 5. And you'll see that this red line, it kind of created a really tall, skinny, happy face. So it kind of looked like that. And if I go ahead and just change this simply right here to a negative x and a 3x plus 7, I'm actually going to do, so we're going to say y equals negative x squared plus 3x plus 7. You'll see that my blue line is now like a big frowny face. So I can get rid of this red one here for a second. So it's like a big frowny face. So we know that if the A is positive, the parabola opens up, and it's like a smiley face. If A is negative, it opens down like a frowny face. And that's the two types of parabolas that we're going to be working with, positive and negative, happy face or sad face. The axis of symmetry is kind of that line that this parabola can be folded over. And so if you look, we can draw this kind of invisible line here at about 2.5. And let's see here, if I do this, if I draw x equals 2.5, nope, 1.5, let's see. That's kind of where that axis of symmetry is, and I could fold this curve on top of itself and it would be the exact same on one side or the other. So the axis of symmetry is the line that splits, the parabola in half. Lengthwise. And there's a formula to find this axis of symmetry, and that formula is x, because did you notice when I came in here to find this axis of symmetry, I'm finding x right there. So our formula is going to be x, hold on, sorry, I gotta go get the right tool. X is going to equal, and I'm going to write it actually, we're going to say negative b, and we're pulling our b from our formula over 2a. So we're going to use the a and the b from our quadratic formulas that we're going to have here. Now the vertex, so if the axis of symmetry is that point in which the line can, or the parabola can fold over itself on this line, the vertex is that either the lowest point or the highest point. It's the point at which the parabola turns on itself. So on our example, on our Desmos here, the vertex is this tipping point right there where the line gets the very highest that it can get, and then it starts going down. So the highest point that a vertex can be is called a maximum. And if our parabola was turned upside down by taking out this negative here, and now we've got our vertex right there. Now it's the lowest point that this parabola can be. So the lowest point is called the minimum. So we have our minimums and our maximums, and those are just representing this point right here. So we've got an example now. We have y equals x squared plus 8x plus 15. The first thing that we're going to do is find the axis of symmetry using this formula right here. Then we're going to find the vertex by plugging in our x value into our equation. Then we're going to just do a quick sketch, and it's literally a quick sketch. It's nothing perfect. So let's start by finding the axis of symmetry, or that line, this green line, or wherever it happens to be, this line that the parabola can flip on itself. So we're going to do this by finding negative, or the opposite of our b, and our b value is right there. So we have a negative 8 over 2 times our a value, and our a value is right here, and that's represented by an invisible 1. So 2 times 1 is 2. So we end up with negative 8 over 2, which is the same thing as negative 4. The axis of symmetry, when I typed over here and I found the axis of symmetry of this parabola, I said x equals 1.5. And that's the point at which we're going to find that right there. So when we know what our x value is, all we have to do is plug in this x value into this equation. And that's going to give us what our y value is, because y equals this calculation here with an x here. Well, we know what our x is, so if I plug that in, it's going to give me what my y is, and it's going to then give me that point that we're looking for to find our minimum or maximum. So I'm going to do -4 squared plus 8 times -4 plus 15. So -4 squared, -4 times -4 is positive 16. 8 times 4 is -32. And then we're going to add this 15 in here. So now I'm going to just simplify, and I know that 16 and 15 is 31 minus 32. Well, that just gives me a -1. So that's my y value. And when I sketch this out, literally what I'm going to do is just kind of guesstimate about where -4 or -1 would be. And -4, -1 is like about right there. And then I have to determine if I'm going to have a happy face or a sad face by this value right here. And so because my a value is a positive number, that means that I'm going to have a smiley face. So that's kind of what my parabola looks like. Go ahead, and if you turn your page, we're going to come down. Really, I mean, we can go in and sketch what these are going to look like just by looking at it. I have a negative, so I know it's going to look like that. Here I have a positive, so it's going to look like that. Where it starts getting tricky is when you have negatives in everything. So let's go ahead and do like number 6 here. Formula doesn't change, so we have the opposite of b over 2 times a. My b is here, my a is here, and I'm going to eventually draw a sketch out. So the opposite of b, which is -24, is going to end up being positive 24. All over 2 times -a. Or I'm sorry, -3. So we end up with 24 over -6, which ends up being -4 again. Did not intend that. So the first part of our vertex is at -4. And in order to find my y, I just go ahead and plug this -4 in for our x's, because that's what that means, is x equals -4. So I'm going to plug that in for both of those. So I have -3 times -4 squared minus 24 times -4 minus 42. So 4 squared is 16 times 3, or times a -3, sorry. It's going to be 48 minus 24 times 4 is 96, and I have a negative and a negative, so now I'm at a positive 96. That's a negative, sorry. And then this -42 just comes down here. Okay, so now I just simplify 48 and 42, that's 90. -90 plus 96, that gives me positive 6. So we get positive 6 up here. I'm going to sketch this. So I'm going to go -4, +6, which is going to be kind of up like that. This time I have a negative a, so my parabola is going to be a frowny face, kind of like that. Hopefully that helps. If you needed some help with 8-1, let me know if you have any other questions. Email me if you do.